Hi, welcome back to another episode of Algebra in Words, the video series on YouTube. In this video, we're continuing our discussion on radicals, and specifically, we're continuing our discussion from the last video on radical equations. In the last video, we looked at equations with one radical in them. In this video, we're going to look at equations with two radicals in them. Before we start, if you want to follow along with the written steps and procedures for this, as well as a few examples, you could follow along with that in my book, Algebra in Words 2, starting on page 78, and the link to the Amazon page is in the description box below. So let's get started. Now, what I have on the board is two radical equations, and in the equation on the left, there is a radical on both sides, and in the equation on the right, both radicals are on the same side. Now, when doing equations with radicals with two radicals in each, there's basically two ways that you can go about it. You can either, and it's your choice, you can either arrange it so that the radicals are on opposite sides, like this one, or if you prefer them on the same side, you could do that as well. A quick note though, if you have them on the same side, you need to have everything else, like the constants or the numbers, on the other side. Before we start, let me give you a brief walkthrough of the steps involved. Now, a quick summary of that is going to be, we're basically going to be doing the same steps that we did in the previous video for radicals with radical equations with one radical. We're going to just be repeating that process twice. However, there's a little bit more to it than that. And a couple quick notes. One thing that we're going to be doing here is recalling the product rule for radicals, meaning if you have two radicals with the same root, you can multiply their radicands together under the same root. You're going to notice that a lot of times with these, the radicands are going to be binomials. So what we could expect is multiplying two binomials and foiling them ultimately, possibly, under one radical. Also, once we go through the first round of squaring both sides to get rid of the radicals, we should notice, and it's normal to expect, that a new radical will be generated, and that's why we have to go through the process twice. The first to get rid of the two radicals, then a new radical is generated, and then in the second round of the same steps basically, it's going to be to get rid of that radical. So anyway, let's get started. In the equation on the left, and also I'm going to erase this one just so we have room to work. These will take up a little room on your paper, so make sure you leave yourself extra space in your notebook. And since these are both the square root, we're going to square both sides. Before we do that, I highly recommend that when you have a radical with another number on one side, I highly recommend that you put parentheses around them, because this will be a binomial, and we do need to treat these ultimately as a binomial squared. So remember, we're squaring both sides to get rid of the square roots. And on the left, that's easy. The radical is eliminated, and we're left with x minus 1. Okay, and now we're going to do the process for a binomial squared. And this is the special process for doing a binomial squared, which I did cover in previous videos. If you're not comfortable with doing a binomial squared, or you get lost here, that's fine. You can expand this binomial and write it twice and FOIL it. But I'm going to go through doing it with the shortcut method for a binomial squared. So the first step is, this is the first term, square the first term, and since it's a radical, the square root of x plus 4 equals the radicand. The square root of x plus 4 squared equals the radicand x plus 4. Now I'm going to square the last term and leave some space. Square the last term. Negative 1 squared is positive 1. And what's the middle term? It's the product of the first term times the last term times 2. And again, if you're not sure how I came up with the middle term, then what you may want to do is expand this and just FOIL it, and you'll notice that the product of the inside and the product of the outside are the same, and that's why we're multiplying this term by 2. But anyway, let's continue. So, as I told you a minute ago, after we go through the first round of squaring both sides, we should expect a new radical to be generated, and that's this. And then we're going to basically repeat the process, but we still now need to isolate the radical like we did if it was an equation with one radical, as I showed you in the last video. So let's simplify everything and move everything except the term with the radical to the left side. So let's subtract x from both sides. And on the right, since we have 4 and 1, which is 5, we're going to subtract 5 from both sides. That's going to leave this term. Let's simplify on the left. And since we had x minus x, that's going to eliminate to 0, so they're gone. And negative 1 minus 5 is going to be negative 6. And that leaves us with negative 2, the square root of x plus 4 on the right. And now we're going to divide both sides by the coefficient in front of the radical, because that's going to ultimately isolate the radical, which is what we want. So divide both sides by negative 2. Okay, and now we finally isolated the radical, and since it's the square root, we're going to square both sides to get rid of the radical. On the left, 3 squared is 9. And on the right, the square root of x plus 4 squared will eliminate the radical, leaving x plus 4. And now all we have to do is subtract 4 from both sides to isolate x. And x equals 5. Now, technically, before we circle that, we should check our answer by taking the 5 and substituting it back into the original equation, putting 5 in for each x, and then simplifying and making sure that the left side equals the right side. And if it does, which in this case it will, then that means that this is the solution and we can circle it. So, just to quickly summarize this problem, this started with a radical equation with 2 radicals in which the radicals were on opposite sides. I put parentheses around the 2 terms on the right, and then, since these are both square roots, we squared both sides. On the left side, the radical was eliminated and we were left with whatever's underneath. And on the right side, we performed multiplying a binomial squared to generate this, which generated a new radical. Then we moved everything except for the radical to the left side in order to isolate the radical on the right side. Once we isolated the radical through simplification, then we squared both sides again. That got rid of the last radical, and then we simply solved for x. So I'm going to erase this and put up the other problem that I had up, in which the radicals were on the same side, and I'm going to show you one of those. Okay, so I have the second problem up, and notice that in this case, the radicals are on the same side. That's fine. And if you determine that you have a preference of having the radical on opposite sides or the same side, you can manipulate it by adding or subtracting one of the radicals to the side that you want it on. But anyway, the steps aren't really that much different. They're going to basically be the same. It's just that we're starting with the 2 radicals on the same side, and we're still going to generate a new radical, and isolate that, and you'll see what happens. Let's start by putting the left side, which has the 2 radicals, in parentheses. And since they're both square root, we're going to square both sides. Now, just to get it out of the way, 1 squared is 1. Let's just write that. And I left myself a little room in case we need it. But my main focus is going to be on the left side. Right now, on the left side, we're doing a binomial squared, like normal, except that our terms now involve radicals with binomials. So now, when we do the product of the first, which would be, when we do, that's right, the product of the first, this is the first term, the whole thing. Think of the square root of x plus 1 squared. And that's just going to eliminate the radical and give you what's in the radicand, x plus 1. All right, now I'm going to leave space in the middle, and I'm going to square the last term, which again, since it's also a square root, the square root of x minus 6 squared is going to leave you with x minus 6. Now we need to do the middle term. The middle term is going to be this term, the first term, times the last term, doubled. And what I'm going to show you just off to the side here or on the bottom is the intermediate step. Now this is going to be recalling the product rule for radicals, meaning if you're multiplying, so let me just show you what's happening here. The first term times the last term is going to look like this. And again, this is recalling the product rule for radicals, meaning if you're multiplying radicals with the same root, which these are both the same root 2, then you can multiply their radicands together under the same root. So it could look like this. That's what that becomes when we use the product rule for radicals. And this is not new to you. This is just foiling two binomials. So that's what we're going to do. Let's just FOIL it and keep it under the radical. So product of the first, x times x is x squared. Product of the outside is negative 6x. Product of the inside is 1x. And product of the last terms is negative 6. Now combine like terms, so underneath it's going to be, I'm going to go from here and write what it's going to become up here now. So when we combine like terms, we're going to have just rewriting the x squared. And since negative 6x and x are like terms, that becomes negative 5x. And negative 6 comes up as negative 6. Also, remember, when we're doing the shortcut method for multiplying a binomial square, it's the first term times the last term times 2, or as sometimes I say, doubled. So since this had a negative 1 here, we can see that as that. Then doubling the product of these will require a negative 2 here. So that's where that comes from. Now you also got to see why I wanted to leave some space in the middle, because the new product was a little bit big. So these steps were to show you where this middle term came from. And if you need to see that for longer, pause the video, but I'm going to erase these so we have more room to work. Okay, so now we want to isolate the variable. And on the left side, we have x plus 1, and we have negative 6. So let's start by subtracting x from both sides. All right, and since we also have 1 and negative 6, which if you agree that combines to negative 5, let's move that by adding 5 to both sides. Now on the left, we're going to have just the radical, plus the coefficient negative 2 in front. And on the left side now we have negative x plus 6 because the 1 and the 5 we added becomes 6. Now let's divide both sides by coefficient negative 2. And we'll deal with, we'll deal with that in the next step. That's fine. On the left, the negative 2 coefficient is eliminated, and now we're left with the radical and let's just rewrite what we have on the right. Alright, and now since we have the radical alone, we're going to square both sides to get rid of the radical. Alright, on the left, the radical is just eliminated, and we have x squared minus 5x minus 6. Now on the right side, it probably would have been better in the previous step if we broke this up, and for now I'm going to leave it as is. So in the top we have a binomial squared, and we're going to square that, and let's just do that here. So if we look at this as a binomial squared, the product of the first term, negative x squared, is going to be x squared. Product of the last term is going to be 36. And product of the first times the last doubled is going to be negative 12x. And since this is over negative 2, we have to square that as well, and that will become positive 4. So let's write that below. And since we have a denominator of 4, now to get rid of that, because it's a fraction, let's multiply both sides by 4. And just so that we have room, I'm going to erase some of the stuff above so that I can rewrite what this equals above, and we have more room to finish the problem. Okay, so I distributed the 4 through the trinomial and wrote that here. That became 4x squared minus 20x minus 24. And since we multiplied both sides by 4, and 4 times the denominator 4 eliminated the 4's, then I just rewrote this here. X squared minus 12x plus 36. And now we're going to combine like terms and solve for x. So let's move everything to the left side, because it looks like we're going to have a trinomial and a quadratic equation here, and we're going to be able to solve it that way. So we're going to subtract x squared from both sides. We're going to add 20x to both sides. Sorry, add 12x to both sides. And we're going to subtract 36 from both sides. So now on the left, we have 3x squared minus 8x minus 60 equals 0. Now we're going to factor this. As the following. (3x plus 10) and minus 6, and now we will set each binomial equal to 0 and solve. On the left, we have 3x plus 10 equals 0. Let's subtract 10 from both sides. And we get 3x is equal to negative 10. Divide both sides by negative 3, and we get x equals negative 10 thirds. And on the right side, we get x equals 6. Take each of those and substitute them back into the original to check to see if they're valid solutions. So that's the end of this video. In the next video, I'm going to do one more example of doing a radical equation with two radicals on the same side. Thanks for watching.